Hello, good morning. Thank you all for coming. My goal today is to present on my preliminary research findings that I have conducted thus far. And while I'm still in the preliminary stages of data collection, analysis, and findings, the process of collecting, curating, and formatting this data has been very strenuous, more so than we anticipated. And thus, we are trying to find automated options to alleviate the burden of these data processing workflows. So my topic today is on modeling bicycle ridership within Northwest Arkansas. This is my MS thesis research. I wanted to do a community-driven aspect of GIS, and this is specifically to predict and validate bicycle ridership estimates within this region. Northwest Arkansas is my area of interest, and I'm in my preliminary stages of research. And this map is pretty much a previous study that I wanted to replicate. It shows from very high to very low estimates of ridership within Arizona. This is a map I made of the current area of interest. And as you can see, the red is the Razorback Greenway, which my thesis is focused centrally on. A quick abstract of what I wanted to do with this study, and basically it's what we are trying to accomplish, what this adds to the existing literature, and basically it's taking the current data that we have from crowdsourced bodies, validating and creating a model that develops and further enhances those estimates to predict ridership within the future, 5 to 10 years, and even beyond that, to give us a rough estimate of how ridership will change within the geographic areas of Northwest Arkansas. Why study this topic? I've been particularly interested in bicycle ridership within communities. It's very low in the US compared to other developed countries. And I wanted to see how we can help improve that. And by calculating all of these ridership estimates, we can provide planners, logisticians, all of these necessary decision makers the tools and information they need to effectively plan routes that are underserved, that are overserved, and allocate resources accordingly. Essentially, I want to map out the trends and patterns. We all know that there are some parts of a city where there is going to be very high ridership and very low ridership, but I wanted to discover where those are specifically in Northwest Arkansas and why that is. This is the method that I proposed, my model inputs, and creating a model that specifically models ridership within this area of interest, and creating a geostatistical model that enables us to find those estimates and replicate those results. Geographical covariates. I used many previous studies to find what they used and replicate my existing study based on their previous methods. And I found that socioeconomic and demographics are probably the two biggest geographical covariates. Not yet validated, but what we proposed so far. And all of these covariates are going to have a direct impact on the model, but we're trying to validate how much and the strength and validity of that impact. What are we trying to show what the data can reveal? We're basically trying to validate accuracy and the compatibility of different data sources, determining the bicycle flow, and the best source and the best methods for bias correction. Conclusions thus far. And so far I found that, like that very first map you've seen in the beginning, very high to very low bicycle ridership is probably one of the best ways to start out introducing people to this idea of ridership estimates within a region, and using that data to be more nuanced and embedded into reports and other findings that back up studies and allocate resources that govern to underserved communities and underserved areas of interest. Future work, there's many things to do left for the future for this project, and continuing to build a robust model and continuing to test the accuracy and validity of that model will be one of our cornerstones. My references. Thank you.